In this video, we'll discuss some questions from your book. So let us discuss page 82, numerical 2. So they are given you the speed of light in diamond. So speed of light in diamond is given. Convert this into meter per second. Okay. So this is 125,000 kilometers per second. So if you convert this into meter, then it will be 125 into 1 kilometer is 1000, so 10 to the power 6 meter per second. Speed of light is also given, so speed of light is given 3 into 10 per 8. So you have to calculate the refractive index of diamond with respect to air. So refractive index of diamond with respect to air will be, visualize like light is going from air to diamond. Okay, so air then diamond. So refractive index of diamond with respect to air is speed of the light in air by speed of light in diamond. We can find it out. Question number numerical 3. Okay, just put this and this will come out. The refractive index of water with respect to air is this. So refractive index of water with respect to air is 4 by 3. What is the refractive index of air with respect to water? So we have to calculate refractive index of air with respect to water. Now, if you guys can recall, we found out that N12 into N21 is equal to 1. So that means N12 is 1 by of N21. So now apply the same thing for this. Let us say this is water, this is air, and this is air and this is water. So the answer will just flip out. It will be 3 by 4. Now coming to question number 27. Okay. Question number 27 is one of the super hit question of board exam or pre-board or our school exam. It has been asked again and again. So page number 82, question 27. So green light is incident, this is given, this is given. Okay. Now in the question they have given this is green light and angle 1. This one they have written at angle 1, which is 45, and this angle is 30. So first they have asked refractive index of liquid. As we were discussing, this refractive index of liquid with respect to air. Okay, whenever they say refractive index of liquid, actually they are asking refractive index of liquid with respect to air. So we have to find refractive index of liquid with respect to air. Now if I apply Snell's law here, then we know that refractive index of air sine 45 will be equal to refractive index of liquid sine 30. So we'll get NL by NA to be sine 45 by sine 30. Okay, this is nothing but NLA, and sine 45 is 1 by root 2 and sine 30 is 1 by 2. So this 2 by root 2. Now you all are scientists, so this 2 can be written as root 2 into root 2 by 2. Why we did it? Just okay, because this doesn't look beautiful. So this 2 to root 2 get cuts, and this is 2 root 2, and if you use calculator, this is 1.4. So it doesn't matter, the answer is root 2. So in the diagram, the path of the ray after it strikes the mirror and re-enters into air, and mark in the diagram the angles wherever necessary. So if you follow it, this part is done. Now this is mirror. So mirror obeys law of reflection, not refraction. Okay, mirror is a polished surface. So any polished surface will obey a reflection principle. Now, what is law of reflection? It says angle of incidence is equal to angle of reflection. So if I draw a normal here, so this angle, you can see this will be alternate interior angle, so this will be 30 degree only, and according to the law, angle of incidence will be equal to angle of reflection. So this angle will be also 30 degree. Now if I draw a line here, it is also obvious that this is 30 degree, again interior angle. Now if you guys can recall, now it's travel from liquid to air, so it will bend away from the normal, and this will be 45 degree. Now this is a beautiful question for the fact that this also takes care of the principle of reversibility. Like we just guessed it. So here what has happened, this part is incident ray and this is reflected ray. Now we have interchanged the ray here by keeping the angle same. Okay, this is nothing but principle of reversibility. So this is the second part. Third part, they asked you redraw the diagram if the plane mirror becomes normal. So in physics, what is the meaning of normal? Actually there is nothing called abnormal in physics, but there is something called normal in physics. So normal means perpendicular, fine. So this, previously it was hitting the mirror, now they have mentioned that the mirror is placed normal, so mirror will be placed like this, so that it makes 90 degree. It doesn't look 90 degree. Okay, so this is mirror. Now it is placed like this. Now this is 30 degree. They are saying now redraw the diagram, the normal, state the principle used. Okay. Now what will happen? Again it will obey reflection principle here. So at this point, this is the normal. So angle of incidence is 0 because it is moving along with the normal. So angle of reflection will be 0 and the ray will retrace its path. So this is again nothing but we are doing what is called, we are using the concept of principle of reversibility. If you interchange incident ray and reflected ray by keeping angles same, the result remains same. Okay, light will take the same time of coming from here to here, then going from here to here. Okay, that is called principle of reversibility. Now I am going to do next question, which is 26. So in question number 26, okay, now we'll do this experiment in the lab also using glass slab. So right now we'll just discuss it here. So this is a glass slab, okay, rectangular glass slab, and suppose one light is incident like this. They are asking you to complete the ray diagram. So this is quite simple. This is, let us write it, this is air, this is glass, and this is again air. So this will be normal, this will be angle of incidence, and it will, if there is no glass it could have traveled in this line, but because there is glass it will bend towards the normal. Again this will be the angle of incidence here, and then it will bend away from the normal. So let us say it's like this. So here this is the angle of refraction, I am writing it R, and you can see this angle will be also same, this will be also R, and let us write this to be E. Okay, so let me just clarify the diagram. This dotted line shows that if there is no glass slab it will go like this. Now this R is the angle of refraction on this, and this R is the angle of incidence on this. Okay, so let me write, this is the X interface, okay, separating air and glass, and this is Y interface, which is glass and air. In the diagram this is how refractive index of this is related. Okay, B part. If you apply Snell's law for interface X, air and glass, then N of air sine I is equal to N of glass sine R. Okay, so this is your first part of B. Now to do the C part, let us also write Snell's law for part Y. So for Y interface where glass and air are sharing the common boundary, we will get Ng sine R. Remember R is the angle of incidence here, and that is equal to Na sine E. Here E is the angle of refraction, okay, for this phase Y. So from this you can see that Ng sine R is equal to this also, and Ng sine R is equal to this also. So in the same way I can equate this into this. Okay, again try to understand this. Ng sine R is here also. So if this is equal to this is equal to this, that means this is equal to this. So Na sine I is equal to Na sine E. So Na and Na get cancelled, sine function get cancelled, and I is equal to E. That means this I remains equal to E. Fine. And if that happens, this incident ray, this was the direction of incident ray, and this is the direction of emergent ray. If this will happen, if I becomes equal to E, incident ray and emergent ray, they will be parallel to each other. Okay. And D part, they are asking which two rays are parallel, emergent and incident ray. Indicate in the diagram the lateral displacement. So what is lateral displacement? The perpendicular distance between emergent and incident ray. Okay, this part, the perpendicular distance between incident ray and emergent ray. Let us say we are representing this part by any symbol T. So this is called lateral displacement. Now they have also asked, state one factor that affects the lateral displacement. So means how this T will change. They are asking you that. State one factor that affects the lateral displacement. So it will be a good guess to think about, like if the thickness has changed, then this will change, right? Huh? Or if this medium refractive index is different, then also T will change. Okay, you can read from your book. So T will depend on this thickness of the glass slab and refractive index, and of course wavelength of light and so on. Once it is related with the refractive index, it is related with wavelength of light also, inversely proportional. Now this is the last question I am going to do. this is page 81, question 22. This diagram is given to you. They are asking you the first part, what is the value of angle of incidence, this, okay, and you have to find refractive index of the liquid. Okay, so see, this is incident ray, this is refracted ray. Angle of incidence is measured between normal and incident ray, so this will be the angle of incidence. So total angle is 90, you minus 30, this 60 is your angle of incidence. And again, this is the normal, so angle of refraction should be measured from here. So 90 minus 45, 45. Okay, so angle of incidence is 60, angle of refraction is 45. How they are related? So you can use Snell's law. Light is coming from here to here, so I can write NA sine 60 is equal to NL sine 45. So NL by NA is sine 60 by sine 45. Okay. Now NLA is nothing but the refractive index of liquid with respect to air. Sine 60 is root 3 by 2 and sine 45 is 1 by root 2. So okay, this will be, answer will be root 3 by 2. Okay, find it out why. There is 2 here, root 2 here. 2 you can write root 2 into root 2. So okay, so let me just magnify this emotional part. So 2 into 1 by root 2 is there. So this 2 you can write root 2 into root 2 into this. So this cancel. So 1 root 2 only survives. So that's why it is root 3 by 2. Now you guys can do questions of, so your assignment will be do exercise 4A completely. Okay, one gift for you guys, don't do okay, fine, completely done. One topic I have not done in this topic, I will talk about it later. Thank you.